The unit circle is a very important concept to know for trig. For this project, I decided to symbolize it with a wheel, inspired by the Wheel of Fortune. As you can see, I even made it actually spin, so you can feel like you're actually playing a game. The unit circle has 4 key points: the x and y axis, coordinates for x and y, radians, and degrees. First, the x and y axis. This is pretty self-explanatory. Going up and down is y, and going left to right is x. This is the center, or 0, 0. The furthest chords from this are 0, 1, 1, 0, -1, 0, and 0, -1. There are 4 quadrants, 1, 2, 3, and 4. Here there are different positive and negative points. To remember which are positive, you can use always skip trig class. This means that all points are positive in quadrant 1, only sine is positive in 2, tangent in 3, and cosine in 4. There are 3 specific sine/cosine points, which are 1/2, square root of 2 over 2, and square root of 3 over 3. These repeat for every coordinate of the unit circle, besides the ones right on the x and y axis. I remember which goes where by remembering that cosine starts backwards 3, 2, 1, and goes back up, and then repeats this cycle, while sine goes up 1, 2, 3, back down 3, 2, 1, and then repeats this. You may be wondering where tangent comes in. Tangent is the slope. Everything I just said is a good way to understand how these trig functions correspond to each other. Their graphs can also be related. Sine and cosine graphs repeat over and over again, but did you know these specific parts are one unit circle? Also, because of sine and cosine being on the unit circle, the Pythagorean identity can be related to the unit circle. The Pythagorean identity is sine squared theta plus cosine squared theta equals 1. Next, there's radians. These pi values are the radians of a circle. 1 full circle is 2 pi. The 2 pi comes from the equation on how to find the circumference, which is 2 pi r. Since r is 1, 2 pi is 1 full circle. One way to find the radians is to add pi over 6 to every plus 30 degrees and add pi over 4 to every plus 45 degrees. This is an easy way to successfully remember all the radians if you get stuck. Lastly, there's degrees. One circle is 360 degrees. On the unit circle, we specifically point out every 30-degree angle and 45-degree angle. For example, the first quadrant goes 0, 30, 45, 60, 90. The circle repeats this process until it gets to 360 and then starts over. These specific points can also be related to the 30, 60, 90, and 45, 45, 90 triangles. The different sides of those triangles correlate to the sine and cosine values. Just an interesting thought to help remember these points. Those are all the basics to the unit circle. These key points are there because they're easy numbers to remember and have many connections. It's always important to understand how the unit circle works and how to get all these key points.